Do you have an idea for an app, but don't know how to build it yourself? Have you always wanted to learn to code, but think it's too hard or would take you too long? Become an Android developer from scratch covers everything you need to start your career as a mobile developer, even if you've never coded before. With this course, you can quickly and easily learn to code in Java, the most popular programming language in the world. It also covers everything you need to know about Android, which is on more devices than any other platform. Divided into 19 sections and over 100 chapters, this course takes you inside the mind of a professional mobile developer. You'll get access to the knowledge, skills, and perspectives that the pros use to make polished applications that are both fun to use and exciting to build. Hi, my name is Adam Lupu. I've been an educator for almost 20 years, the last 4 of which I've spent researching how novices learn to code and how experts hone their skills. I've worked with over 1,000 students from all over the world, and I've discovered some really cool techniques to rewire your brain and learn mobile development faster than anyone, including myself, thought possible. So I teamed up with the best mobile developer I could find to create this course.
My name is Adam Schwemm, and I've been a programmer for over 15 years. I've worked with Sony, Nvidia, Verizon, developing apps like Shazam and Music ID. I built the world's first video streaming app store for Android when others thought it wasn't possible. I think mobile devices are the closest thing we have to magic, and I'm excited to guide you in building software that you can be proud of and apps that are truly engaging. In this course, you'll use the most powerful development tool available, Google's very own Android Studio. With this cutting-edge IDE, you'll create responsive UI navigation, craft multi-resolution applications with fragments, use advanced libraries to leverage the power of third-party APIs, and access hardware sensors to take full advantage of what the latest Android SDK has to offer. All course materials, including everything you need to get started, will be available for download, and lessons will come with carefully crafted visual aids to help you understand everything you need to know.
On top of that, we're excited to offer you our code-alongs. The code-alongs give you the chance to build applications right alongside a professional developer and a learning scientist. Find out why the pros are having so much fun coding mobile apps.
This is quite simply the best Android development course available online, and we want to keep it that way. So we will be here to answer your questions and create new modules that will help you keep your skills up to date.
Isn't it about time to launch your new career and build amazing mobile applications? Let's get started.
I is going to introduce you to Android Studio. But before we take a look at the application, let's talk a little bit about Java. So you could, if you really wanted to, write your entire application just using a text editor. The problem with that is Java has lots of different pieces and files, so you really need some help in terms of maneuvering through your code, and that usually comes in the form of an IDE, like Eclipse or Android Studio. An IDE stands for an Integrated Development Environment. So think of it this way. Android Studio is going to take care of managing all your code, and we're going to take care of the rest. So let's go over some of the features of it. I'm going to start it up, and the first thing that I love about Android Studio is the startup experience. Normally you have to write a bunch of things in the very beginning when you start a project, but here we can kind of go through a wizard that's going to help us set up the very basics for many different types of projects. Remember that Android is not just for phones, it's also for wearables or even Google TV. I'm going to go ahead and create just a phone project to start up, and you can see that we have all these great templates. So rather than having to do a bunch of boilerplate stuff in the beginning, it starts us off with a really good starting point for many of the different types of applications we'd want to create. Don't worry about me kind of running through this very quickly. I'm just trying to show off the IDE. So one of the things that's also really great is an IDE usually gives you a lot of feedback about what's going on in the background as it's doing stuff for you. This allows you to concentrate more on what you want to build and what you want to code, but at the same time it's going to give you little hints throughout the application, especially along the sides. You can see down here it's updating some indices. You can see that there's some processes running. So it's always doing stuff for you, and you can often get that feedback without it overwhelming you right in the front. Now, if we're going to be creating code to so many different types of devices, what we really need to be able to do is see what it's going to look like depending on the form factor and device. And Android Studio has this great integrated editor into it, which allows us to look at the same view and instantly change what the actual object is that it would be running on. Not only for tablets and phones, but also for wearables and even Google TV. Now there's a lot of other features that I'm not going to go over and show you directly because it's not really important, but there's all this other cool stuff. In Android Studio you also have a international string editor, so it makes it really easy if you want to have multiple languages for your project. It also integrates with Google's backend services, so that even if you're not a server engineer, you can actually get part of your application to integrate with Google that way. And it's all just built in a really nice package. For me, there's really one main reason why I love Android Studio, and that's that it's fast. When you're creating code in Java, usually what ends up happening is you start trying to type some code, and you can't keep all that stuff in your head. So what Android Studio does is it actually has one of the fastest code completion algorithm sets that I've ever seen, which allows you to really quickly start to see options for your code. It auto-completes things for you, and it just makes it much easier as you're looking at particular pieces of your code to get help as you're coding. Eclipse also does this. It's another IDE, but IntelliJ, which is what Android Studio is based on, is so much faster and so much better. On top of that, sometimes you'll have a particular change that you want to do throughout your entire project. Well, in Eclipse, and granted it does it very well, but it just does it so much faster in Android Studio. Here I want to change the name of this particular class from main activity maybe to something like awesome activity. So not only is it going to change that, but it's going to look for usages, change the file names, and everything is just going to work. So I can think about what I want to change it to rather than having to worry about, oh, did I miss it somewhere? Again, it's going to take care of all of the code management for you. And it's so fast, fast, fast. Now, being fast is great, but sometimes when we're developing, what we really want to do is we want to slow things down. And Android Studio also has a really, really great debugger. What this means is that rather than having to pay attention to how to get the data from what's actually going on, we can actually take a look at things step by step and move through them step by step and see how data changes. This makes it so much easier to troubleshoot problems. So just to summarize, Android Studio, it's not only an awesome tool, but it's also what we're going to use throughout the course, and it's what's going to empower you to not waste time worrying about managing your code, but instead focus on making really cool applications. What are the different avenues we have to actually run and test our code? Well, the first one is we have the emulator. The emulator comes with Android Studio and the SDK, and it's pretty slow and sluggish, but it comes already installed and raring to go and allows you to customize and simulate different phones. The second avenue we have is an actual physical device. Now, devices are incredibly accurate. I mean, you're actually running the code on a physical phone. The problem here is that can get pretty expensive, especially if you want to test on 100 devices, because Android runs on so many different types. Your third option is to try something called Genymotion. Genymotion is my particular favorite because it doesn't just emulate a phone, it actually turns your computer into a really powerful phone. So it's incredibly fast, faster than even running on a device. It's also, like an emulator, very cheap. You can just go through as many different devices as you want and simulate them and test things out without having to purchase a whole new piece of hardware. So professionals in general use whatever they particularly prefer. I tend to find that if I have a bug on a very particular device, I will actually test it on a device. But at this point, I no longer use an emulator at all. So why Genymotion? Well, to start off with, you have the ability, rather than having to configure the emulator, to actually go and connect to them and just download different pre-made devices already. Many of these are common ones. You can also customize them, but it's much easier just to download exactly what you want rather than have to set it up yourself. Once you actually have a particular phone running, you'll see this screen. This is the actual emulator itself, or Genymotion itself. Now, you can simulate so many different things outside of it. You can start to mess with the charging level and whether or not it's charging or discharging. GPS is amazing on it. You actually can just go to a map and you can type in a particular location. It'll find it, and then it'll have the latitude and longitude. You can change the accuracy. All the things that you might want to do to test your device outside, you can just mess with the settings directly. On top of that, you can also connect the camera to your webcam on your laptop, which helps you when you're trying to troubleshoot things that have to do with, camera applications. It's much easier to just quickly go through that experience rather than having to wait to deploy to a device and then move it where you want it to look. So anyway, if you're somebody who's just raring to get started, go ahead and use the emulator or a device if you have one, or if you're just having some issues getting set up, just go ahead and go for it. But if you're willing to go through setting up VirtualBox and creating an account with Getymotion, I highly recommend it. It's what we're going to be using in the course, and it's one of my favorite tools that I use for Android development.
Hi there, and welcome to the Delta program. For the past 40 years, if you wanted to learn how to program, you'd start with this: Hello World. In whatever programming language you were learning, you would attempt to get this to print to the screen. 40 years ago, that was truly amazing, to get a machine to actually communicate with the outside world. Problem is, 40 years later, not so cool. Now we have these amazing devices in our pockets: mobile phones, smartphones, Android phones, and we want to be able to build applications that wow our friends. Seeing Hello World on the screen is not going to cut it. So join us in saying goodbye to Hello World and hello to your future as an Android developer. One of the coolest things about learning to code is the amount of detective work you get to do. Reading and understanding a programming language is kind of like being Sherlock Holmes. You start seeing all the angles and being able to interpret all the subtle details. And the best part about it is that you already have all the experience necessary to make a great detective. If you've chosen to participate in this course, you're probably quite familiar with mobile applications. For those of you who are new to Java, we are going to fully leverage that experience. Here's how. Take a simple application like the one you see here. It's a list of pages that I like on Facebook. It scrolls up and down. It interacts with the Facebook database to get an image and a name. I'm sure you've seen several similar applications with familiar functionality before, but here's the really neat thing. Everything that you notice in this application is somehow expressed in code. In fact, every application you've interacted with is expressed somehow through code. So if you can identify a specific behavior in any application, you can start to play the part of a code detective. You can locate the code that relates to that specific behavior, and with just the tools I'm going to give you in this unit, you can begin to understand what the code means and how it works. You can do all of this without having to suffer through years of training in computer science or mathematical thinking. And the coolest thing is, once you develop the skill of being a code detective, you can learn more about the process of developing applications simply by using them. So put your detective hats on. Join me in asking questions and getting curious about what you see. And together we'll go on a journey from application to code. Before you know it, you will be reading and understanding the Java programming language, the very core of Android application development. In order to be a good code sleuth, you need to be able to examine the scene of the code. When a professional Java developer looks at code, they quickly scan for 4 things. Thankfully, because of the way Java is set up and used, these 4 elements of the code are pretty much always in the same place. So all you need to do is train yourself to look in these 4 locations. We start with a file. A file is for storing specific functionality related to something your application is going to do. Each file contains a class that will, by convention, carry the same name as the file. Now, classes are one of the coolest parts about Java, or any other language we would refer to as object-oriented, but we're not going to get into them right now. You don't need to know any specifics about what a class is or how it works at this point. Just store that away as one of the core questions of your ongoing detective work. For now, all you need to do is train yourself to recognize the location of a class inside a file. Okay, here's where it gets interesting. In a class, there are 2 basic sections of code. At the top are the attributes. You might also call these properties. They're basically the substance of a class. They are the things. For example, a car class might have a certain number of wheels as an attribute, or an animal class might have a species attribute. Below the attributes, you'll find the methods contained within a class. The methods are the most powerful part of application development. These contain the actual functionality of your application. In our previous example, that scrolling I was able to do, the requesting and receiving data from Facebook, all of that functionality is housed in the methods of the code of that application. In fact, most of the clues you will use to solve any code mysteries you find will come from your ability to interpret and understand methods. So that's it. That's Java. You have a file that contains a class, and the class contains both attributes and methods. Don't believe me? Here it is. As you can see, each part of the code has its own particular section. So as you develop your skills as a coder, you will understand how important it is to stick to a convention in which you put the attributes at the top, followed by the methods, and each class is named after its appropriate file. This is what you do. You train your eye to look at the class, to examine the attributes, and to scan the methods. It's what professional developers do, and it's what you're going to learn to do now. But before you can dive into methods, you have to learn the lay of the land when it comes to coding, and that is syntax. We'll go over that next. Syntax is usually what scares novice coders the most. It's not what we're used to seeing. It's a lot of funky characters that you probably haven't even ever typed out before. But it turns out that syntax is the best source of clues to look for. And professional coders use these symbols to read and understand code with ease. Not because they have vast knowledge from years of study, but simply because they've trained themselves to notice and interpret the most common symbols, as well as question whenever new symbols appear. So I'm going to show you all the most common symbols to look out for. We're going to give them names, and we will refer to them throughout our conversation. It's going to be your job to see these symbols not as inscrutable barriers to learning how to code, but instead as your greatest allies in interpreting and understanding what the code is really saying. So here they are. The first, and most important, are the braces. Sometimes called curly braces because of their curly shape, braces are used to contain an entire code block. So they are very handy at giving you something to look for that reduces what you have to focus on. They basically communicate, hey, everything between the opening brace and the closing brace is related and distinct. Use them to visually reduce the amount of code you have to look for at any given time. As you can see here from the example, with the braces highlighted in red, there's an opening brace and a closing brace. Sometimes they won't be on the same line, but between them contains a single block of code. Next up is the semicolon. This one should be a little more familiar. It's actually used in code to represent a completed statement, or the end of a line. If you see this, you know that everything that came immediately before it is part of one line of code. So for instance, again, highlighted in red, everything to the left of the semicolon in the example is part of that one line. So with braces and semicolons, you can identify blocks and statements. Now it starts to get a little subtler. You have to look for more details. So let's start with parentheses. Parentheses are a new concept. They are not going to be what you're thinking of when you see parentheses in written English. Instead, in this case, they're actually having to do with passing in input, passing in what we call parameters. They can also be found when calling a method or initiating a method. As an example, you might see an ask name method, and input would be my name, Adam. So you'll see these parentheses wherever something's being passed in, being offered up as an input. You're also going to come across brackets. These are squarish in shape, not like parentheses or braces. They don't have any curve to them. Brackets are primarily used for data objects, or the position of data in a collection of data. As you can see in the example, we have the number 4 contained between two brackets. The brackets are part of the definition of this int group, and 4 happens to represent is a clue to represent the number of elements in that group. Operators. You'll see these used all over the place. Operators may look similar to other symbols that you've seen before. We have an equal sign, an exclamation point, an ampersand, a plus symbol. These operators are not quite what you're used to. They're used for reference assignment and logic. So if you see these, don't automatically jump to conclusions. You're not shouting in your code when you use the exclamation point, and the equals sign doesn't actually mean equals. So be careful. Here are some examples. Don't worry too much about what this code is saying. Just notice that the symbols can be used in combination. You can have a exclamation point and an equals sign, what's sometimes referred to as bang equals, or two ampersands, two plus signs, two equals signs. So you'll see these operators used both individually and in combination. That's all of the syntax you really need to look out for at this point in the course. Braces, semicolons, again, those are the two most important ones. Then parentheses and brackets, and finally operators. So be on the lookout for these. These are the clues that are going to help you distinguish what's a block of code, what's the end of a statement, where are we passing some kind of information in, where are we looking at the position of data, or how are we interpreting the logic. So that's the syntax. Now, one thing that you might have noticed from my examples, there's this uppercase and lowercase lettering situation happening. And I would like to explain why that's going on. In Java, there are specific ways we use casing, or uppercasing, lowercasing, capitalizing letters. First off is camel case. This is the most common thing you'll notice in Java. Camel case, the first word of the phrase is lowercase, in this case camel, with a lowercase c. And then the second word in the phrase, or any other successive word, second, third, fourth, fifth, will all start with a capital letter. So in this example, case starting with a capital C. Camel case is used for method names. Whenever you're defining your own name for a variable, you'll see camel case used quite a bit. You will also see Pascal case. Pascal case is different from camel case, as you can see, because every word in the phrase starts with a capital letter. As an example, Pascal starts with a capital P and case starts with a capital C. Now, if you're familiar with other languages, you might have also seen snake case. Snake case has this underscore that joins each word in the phrase, and then all words are lowercase. Now, we are not going to use snake case. It's not part of Java convention. So ignore snake case for now. If you've been using it in another language, just understand that it's going to look weird if you program with snake case in Java. So now, whenever programming in Java or reading Java code, you should know your case. Now that you've been exposed to all the most important visual clues to look out for, you're ready to dive right into the core detective work of being a Java developer, reading and interpreting methods. You now know that a method stores and expresses specific functionality. So let's look at how it does that. We have to start with the method signature. The method signature is the collection of code and instructions that define what goes into and what comes out of the method, what gets run when the method gets called or triggered by the application, as well as who can access the method. Every method has a unique signature, and every method signature contains several clues about how that particular method is supposed to work and what functionality it provides your application. Thankfully, all method signatures follow the same basic format. Notice that there are 5 components to a Java method signature. The first component is the accessibility keyword. There are several different kinds, which we will cover later, but this basically defines what has access to this method. The second component is the return type. This defines what type of data the method must return. In this example, void means it doesn't have to return anything. Third, and most important, is the method name. If you want to reference this method anywhere else in your code, the method name defined here in the signature is what you have to call it. Now comes a parentheses. This is one of 4 symbols to look out for in a method signature. Every method signature requires them to be ordered properly in order to be properly defined. You can see it's an open and close parentheses after the method name, and an opening brace and a closing brace. The braces are the most important thing to scan for visually when you're reading code. They will tell you where the method starts and ends, and where to look for the code it contains. As you can see, I've said code goes here after two forward slashes. That actually is meant to be a comment, and we'll get into more of that later. But that's not actual code. I'm just suggesting to you where in the method the code should go. The parentheses house a special part of the method signature, called the parameters. These are basically the inputs for the method. In other words, they are what the method requires you to give it in order to run properly. In a method signature, each parameter definition requires two things: a data type, in this case string, and a generic name, in this case a sortable string. The name of the parameter is just a reference. Once it's been written here in the method signature, that reference can be used anywhere within the block of code between the braces. In this case, a sortable string will refer to whatever string object you offered up when you called this method sortString. Don't worry if you only partially understand what I've described here. Your understanding will start to crystallize over the next couple chapters. But for now, it's important to be able to identify each of the parts of a method signature in actual code. So, let's see what you got. Here's an example of an actual method. If you want to test yourself, pause the video and identify the 5 components of the method signature, starting with the syntax symbols. Okay, now let's go over this together. The braces represent the beginning and end of the code, as you can see them here and here. So this entire block of code is the method signature. The parentheses are most helpful in telling us, the parentheses here and here are most helpful in telling us where to look for the method name. And as we can see, the method name comes before, and is in this case, round corner image. So when you refer to this method elsewhere in the code, you should expect to see round corner image as the name used. Notice also the camel case used to define the method name with the lowercase r, capital C, capital I. Next up, let's look left of the method name, and we find bitmap. Again, this is going to be the return type. You may not know what a bitmap is, but you can safely say now that this method better return one, or it won't be adhering to its method signature. You also see the bitmap data type used again in the parentheses here. So the method takes a bitmap and returns a bitmap. It turns out a bitmap refers to a type of image data. We are going to refer to whatever image data we passed into this method as src, as you can see here, an abbreviation for source. So you can see src popping up throughout the code within the method. Here, here, there's another one down here. Every time we use src, we are referring to the image data we passed in as a parameter of the method here. Now, if you're a good detective, you should have noticed that there's something else in the parentheses that we haven't talked about yet. It's this comma. There's a comma, and then there are 2 more words there, float and round. Well, can you guess what the comma means? It indicates that there is more than one parameter for this method. In other words, to use this method, you have to input not just a bitmap, but also a second parameter, in this case, a float. Now a float is a specific type of number data. It actually gives you the ability to use decimals when defining a value. And here, we're going to refer to it as round. Now see if you can find the uses of the word round in between the braces. Okay, the only other thing we haven't talked about is the accessibility keyword. In this case, public. That just means you can access this method from anywhere else in the code without restrictions. For now, that's fine, but we'll talk later about the other types and why accessibility is so important. So let's see if you can put all these clues together and deduce what this method does without having to read through all this code. Ready? Well, you have a method called round corner image. it takes a bitmap, and it returns a bitmap. It also takes a number. Can you guess what it does? Pause now if you need some time. Okay, if you think that this method takes a picture and rounds the corners, and then returns the round cornered picture, you're right. This method is for rounding the corners of an image. The amount to round is actually given by the number you pass in as a float, and the image to be rounded is the SRC, or source bitmap. In fact, round corner image is the very same method that allows my Facebook likes to have these nice round corners on the images on the side of each row. So there you have it. That's your first example of using the clues in the code to read and interpret a Java method. Now, let's dive into data, or what I like to think of as the real currency of an application. And let's see if your detective work so far can lead you to a big payoff. Alright, now you're really cruising along. You've learned how everything in an application is somehow expressed in code. You've visually identified files, classes, methods, and syntax. And you've taken apart a method's signature piece by piece to discover what it did. Now you're ready to go one level deeper in your investigation. Java is just a programming language. It is built to handle data in cool and useful ways. But in order to use it wisely, you have to understand what types of data it's built to manage. Data is really the currency of an application. When you select something in a mobile app, you want to be given the right data. You don't want to ask for someone's email and get their phone number instead. You don't want to call someone and be routed to someone else. How you manage data is critical to how well your application performs. Think of it as data on demand. Can you accurately deliver the right data at the right time whenever someone uses your application? So let's start by identifying some of the common data types in Java and how they are defined in code. I've created a class here called myInfo. Notice the Pascal case with capital M and capital I. We will use Pascal case whenever we define a class. The class is contained within these two braces. So right now all my class is just a collection of attributes. Inside my class I've got 5 attributes and so far 0 methods. But that will change soon. Let's take a look at my attributes. The leftmost word is the data type of the attribute. These are 5 common types of data that you'll see used quite often. There's an int, which is basically a number, a string, which can be any string of letters and numbers, what we might call alphanumerics. There's also a boolean. This can only have 2 possible values, true or false. Then comes a char. It's used for whenever you need a single character, in this case, my middle initial, J. And finally, a float. This is for a decimal value, like my height in meters. You'll notice also that there's an F at the end, which signifies that we have a float, as opposed to some other type of number. So now you see that there are data types, followed by some kind of name that we're giving them, and then the equals sign, which actually assigns the value, and then the actual value. For a float, 1.87f. For my middle initial, we have J. My boolean for ismail is true. My name is Adam, and my age is 33. Now, one other thing about all of these names that we've given here. These are variables. We have basically said that we are creating an int type variable, and it's going to be my age. Then with the equals sign we are assigning the number 33. So wherever we see my age anywhere else in this class, it's going to be 33 unless we change it. So let's update this information for a few months from now after my birthday.
I'd like you to think of memory as a series of lockers. There's a lot in common with
I'm going to show you how to speak computer. These handheld devices that we have, these smartphones, these computers, are so powerful because of one main invention: transistors. Well, what's a transistor? It's actually just a switch. It's either off, or 0, or on, 1. So how does a simple idea like just off or on translate into all the cat pictures and streaming videos that we love so much across the internet? Well, let's play around with this language and see what we can do. Imagine that we had 8 distinct lockers, each with a switch inside of it. If we wanted to start actually counting with these switches, we could just flip the first one up for 1, but then where do we go? Well, this is what is considered binary, the idea that you only have 2 states, and it's the language of computers. We can actually just keep carrying things over the same way we would with decimal in order to actually add larger and larger numbers. So we could go from 1 to 2 by moving over and flipping the switch on that side, and then flipping the switch back on the 8th block to 3, and then 4, and so on. This gives us a total of 256 different states that we can describe using just on and off. Well, what if we wanted to represent something like a negative number? Well, we could just take that first locker and use it as a switch to denote positive or negative. And in fact, this is how computer memory actually works. It's really just mapping these different states to mean different things. So let's take that and let's go in one level deeper. Rather than having 8 bits, let's actually represent just one locker as 8 bits, or a single byte, and move that kind of out so that we can represent, a single number more concisely. Okay, so if we have 4, and let's say we had like a bunch of other kind of random numbers, what else could we express besides just numbers with this kind of counting system? Well, we could actually map those numbers to mean different symbols. For instance, we could actually have them be letters and say that A equals 1, B equals 2, etc. It's not exactly quite like that. You actually start up in the 60s when you're doing character calculations, but you can get the point that you can actually store character data as numbers if you had a system that you could rely on. The idea of storing little bits of data in these lockers is a really good metaphor for how allocation actually works inside of the Java virtual machine. Accessing memory is just as laborious as having to go from one locker to another to open and access data. That's the reason why computers like it when you store things contiguously. If we want to have a bunch of things that are very similar, we can actually put them in memory all next to each other. Computers are very good at accessing memory that's stored contiguously in a row, kind of like a bully who's running down the hall and opening all the lockers up at once. The problem with running down a hallway full of lockers like this, though, is you need some indication of where to stop. We use something called a null terminator to describe where you actually want to stop data. This is just a symbol to represent a kind of special code, which means, hey, stop reading the other lockers. So it allows you to put something actually in memory and then have the computer run to it and stop. Now you can imagine that if you had millions of lockers, you could store some pretty complex data. Well, the one problem with that is, as you saw, we can read and that's fine, but with larger and larger data sets, we're going to have to read a lot more data and move to a lot more lockers if we ever wanted to actually move data around. Now comes one of the coolest things that you can do with memory. In order to actually describe that dog is in locker 1, 2, 3, and stopping on 4, all I really need to do is describe locker 1. If you knew that I'm going to have to go to locker 1 and run through it until I stopped, then you could just store that entire dog word in locker 5 using a pointer. In fact, you could store the same data in locker 6, 7, and 8 and use up only the same amount of memory that it took to originally store it. This idea of referencing data is a fundamental aspect of Java, and it's incredibly efficient at being able to point to data without having to copy it. You can see that in memory, the type of data is really important to be able to know how to actually get it out of these lockers or out of memory. So I'm going to show you now all the different types that you need to know in order to be an excellent programmer. There's basically two kinds for Java. There's primitive data types and reference types. Primitive data types start out with just the simple Boolean. Think of that as like a switch. It's either 1 or it's 0, on or off. One that requires a little more storage is the byte. This is basically 8 different switches. We'll often use it for storing just raw information. Next we have our numbers. Basically all of these are integers, so short integer, an integer, or a longer integer, each one having a little bit more space for a bigger and bigger number. They're also all signed, which means that we can express them as negative or positive numbers with that type of data type. So numbers are all well and good, but we are going to also need characters. It's going to make it much easier for us to express ideas like words. And finally, there's floating point data types. If you ever wanted to express something like, 3.14 or anything with a decimal point, if you wanted a little bit of precision, you could use a float, or with more precision, you could use a double to express that floating point, almost like a scientific notation. And now for the other side of the column, reference types. Under reference types, there really is only a reference type. It's just a memory address. It's just storing a pointer to some other place in memory. And this is what's going to allow us to build incredibly complex pieces of data by combining the primitive data types with the reference type. So as you can see, each of these kind of increases how much you're using of that memory a little bit and a little bit. As programmers, we want to use the least amount of memory needed in order to be efficient. By doing so, you'll have a lot more space left over for building your awesome applications. Now that you have a basic idea about how memory works, I'm going to show you what primitives in Java look like in actual code. So, let's start with the smallest of all the primitives, the byte. Bytes have a default value of 0, and they kind of look like this. Again, just 8 different switches all set to off. So this would be an 8-bit word size underneath the hood. The next one is short. Now, shorts are larger than bytes, but they're still a default 0 when they start. And they are 16 bits, which means they look kind of like this underneath the hood. The next is probably the most common one we use as Java programmers. It's an int. I'm using short for integer. It also starts at 0, only it uses up 32 bits. Well, maybe we want to have a number that's just not able to be expressed with 32 bits. And for that, we have a long. Its default value is also 0, only it uses a whole 64 bits in order to describe the number it's going to describe. So, this is fine for integer values, but what if we want to express something like 3.14, or we want to express something like 0.00001? Well, That's where floating point and double come in. Floats, as they're called, are denotated by having this little f right there, so that Java understands that we're talking about a floating point number. Now I'm not going to keep typing all these zeros out, but I will tell you that this one is 32 bits. You can use a double if you need a little bit more precision. Its default value is also 0, but it uses a whopping 64 bits, which is great if you really need some precision. Okay, so those are kind of all the number primitives, but there's still the char primitive. Sometimes it's called char. I don't particularly know what the actual pronunciation is, but I like to call them char. So its default value is basically like 0. Oops, there we go. My char equals that. Again, it's basically like a mapping of numbers to letters, with A starting around 65, a capital A. So I don't actually know what this symbol is in Unicode, but I do know that chars take up 16 bits. Finally, my favorite, the Boolean. They start with a value of false. They can only be true or false, and they take up 1 bit. So that's basically all of your primitives. So this idea of doing more complex operations in memory requires us to have a basic understanding of references. References are not the same as values like primitives are. References are pointers. So let me show you what I mean. Let's say we wanted to create an int array. So this is an array of ints. I'll just call it my int array. And we're going to have to specify when we first create it the size of it. So this means there's 4 different positions, 4 different memory lockers, each of them being an int. We can actually put stuff in those lockers by describing which position. In this case, I'm saying the first position, or the 0th position. And I'll say, let's make that equal to 2. Okay, so what has happened here is a couple things. One is that this particular piece of memory is being assigned 2. That's fine. This particular piece of memory is just a reference. It's not pointing to the actual value. It's pointing to an area in memory. And it knows that that area of memory will end after it gets to 4 positions. So let's go ahead and fill this array up with some more values. I'll put in maybe just even numbers for now. Just really simple and basic right now. And you'll notice that when I'm doing this, that the last position of the array is 1 less than the size. That's very important to know. A lot of programmers will come across these off by 1 errors because arrays tend to start with a number of 0 as opposed to 1. So this was fine because I created some data, but most of the time you might not actually need to have that data ready and available at that very moment. You might want to just create a reference for future use. So in this case, let me say my second array, and I'm going to do this. Now, what is this one's default value? I didn't actually allocate it like I did up here and create a place in memory for it. What it's actually equal to in the beginning is something called null. In fact, this statement right here is equivalent to saying this, if you don't define it right off the bat. What is null? Well, null is kind of like nothingness. It means this isn't pointing to anything. And you have to be very careful about dealing with things that are null. Oftentimes we create objects and create situations where we haven't quite set them to be what we're going to use them for. An example might be this, string my name. And later in my code I might actually say what that is. My name is Adam. Now I've gone from pointing to null to pointing to an actual string of data. Java objects do this all the time. Primitives will always have a value, but any type of reference type, which is pretty much everything else in Java, is always going to start at being pointing to nothing. It's up to you to actually point it to a useful part of memory. Let me show you something else that's interesting about this, so you can actually see how this assignment works. If I now say my second array is equal to my int array, then this particular variable is pointing to this data in memory. If, however, at this moment, I say my int array is equal to null, I'm not somehow deleting this memory at all. I'm just saying from this array, my int array, point, somewhere over here. Point into nothingness. Point to nullness. My second array is still pointing to this data right here. So managing these differences of pointing to actual memory or pointing to null is what's going to help you troubleshoot your code to make sure that things are working how you want. Every good professional has their environment. A good mechanic has his garage. A good cook has his kitchen. For us, our environment is going to be the Android Studio IDE. Android Studio and Eclipse are pretty much the main development environments that people use for creating Android applications. Android Studio is based on IntelliJ's engine, which is just loaded with tons of really awesome features. There's a lot of smart editing. You're going to find that code gets completed for you. It has a really amazing layout editor, so you can actually see what something is going to look like before you actually put it on a device. It has all these template-based kind of wizards to basically set you up halfway into what you want your application to be. And specifically, this lint tool analysis feature of Android Studio just crawls in through your code, finds out really where your problems are going to happen before you get to them, and gives you a lot of feedback to be able to code easier. It's almost like having an assistant with you while you code. So let's go ahead and open this thing up and take a look at it. So you normally would just drag Android Studio to your applications folder. I'm going to use Spotlight actually to start it up. Now if you're a Windows user, everything that you see here, there's going to be an equivalent. The only difference is that when I'm using this particular key, which is the Command key, you're probably going to be using the Windows key. Otherwise, most of the shortcuts are going to be very similar, but we're going to use OS X for the duration of our exposure. The first thing we have to do is actually get our brand new Android Studio IDE to be set up to use the Android SDK effectively. So before we open up anything, we're going to click on Configure. Under Configure, there's this little guy here called the SDK Manager. If you click that, what you're going to get is this interface that basically allows you to configure what of the SDK is installed on your machine. So I already have all these things kind of set up, but I'm going to highlight what you should actually click and install so that you are up to speed with where I'm at. So the first thing you want is you want all the SDK tools. Just click this guy on the left and get them all. The next thing you're going to need is actually a particular Android SDK. I recommend starting with KitKat. You could use some of the other ones. Let's not do that right now. Let's just use the cutting edge. And this is awesome. You're going to love all these different features. And so I'm going to use the Android Studio KitKat 4.4 here. And again, click right here, get all of the different pieces for that particular folder. Then scroll down to the bottom, and under Extras, we want to grab a couple more things. We want the support repo and support library, so these two guys right here. And then we're also going to want the Google repo. Now, if you happen to be a Windows user, you're going to want to also download this USB driver, and that's going to help you actually connect to a physical device. However, if you're using OS X, we don't need that one. So here we go. We would just click Install. I'm not actually going to go through with this, but just to show you, if you click here and you click Accept License and Install, it will then install all of the particular components that you don't have yet, and that's actually going to take a while. So if you want to go and get a cup of coffee, maybe some tea, enjoy outside for a while, it'll take a bit to download, and then we'll be right back. Go ahead and double check that your SDK path matches what you see here, or similarly. Again, for Windows users, it will be a little different. But you do need to actually point to where the SDK is for Android Studio to be at its best. Alright, so let's go ahead and see if we can get an application running for the first time and make sure our setup is exactly how it should be. So, I went ahead and downloaded Delta Bartok and have the folder right here. I'm just going to go back, and I'm going to go to Open Project. I'm going to select that particular folder. This is where everything will be for your projects. You'll see kind of a Gradle folder and then the actual application name. You actually just want to select the folder to open a project. And now here you are, running one of the most powerful IDEs on the planet. So before we start actually running and testing this thing out, I want you to notice something. Down here is a little indicator. Sometimes if you open up a project, it's got to do some configuration in the beginning. So don't just jump ahead and start clicking things. Wait for any type of information down here to finish. Remember, it's doing a lot of work for you. Please let it. Now, before we even open a file of Java and actually start looking at code, let's configure Android Studio to be what a professional would really want it to be. I'm going to open up this little folder here. Again, right here is the projects kind of area. This is just a file structure for your project. But I want to just show you the normal look and feel of Android Studio. It's missing two key things. One, there's no line numbers, so we're going to turn those on. Two, this particular color scheme is very bright white. In order to reduce the type of fatigue that you would normally have with just white being in your face all the time, we're going to choose the Darkula theme, which is going to make Android Studio look a lot cooler as well. So that's here under Android Studio. I'm going to go to Preferences. The first thing I'm going to change is take Theme and change it to Darkula. Then I'm going to go over here to Editor, open up the editor, and then go down to Appearance and click this guy right here, Show Line Numbers. Then I'm going to click Apply, and it's going to say, hey, you're going to need to restart Android Studio. I'm fine with that. And now you're actually running a Android Studio IDE set up the way a professional would use it. So let me give you a small little tour. Here we have the code window. This is where you're going to be spending most of your time. Over here is your project window, which I kind of suggested before. Each of these are folder files, so you can navigate to all the different Java files and resources that you want on the left-hand pane. On top of that, there's a lot of hotkeys that you can use to maneuver around your windows very quickly. I can make this disappear and come back using Command 1. Again, this is one of the most powerful IDEs on the planet. I'm going to actually turn off my keyboard UI pop-up just so you can see that when I start typing things in Android Studio, I'm just going to get information overload. Things are going to pop up. They're going to try to anticipate what I want to say before I say it. And as we go through the program, you're going to see more and more of exactly how to use those autocomplete utilities to your advantage. But for now, let's go ahead and get something actually running. I'm going to go over here to this res folder, and that's usually where Android Studio will put anything that's a resource, so images or descriptions of how things look. In fact, I'm going to go into res and layout and double-click this XML file right here so you can see this really awesome layout editor. Normally, you would have to do this kind of stuff in code. Back in the day, you had to do all this stuff manually. However, now you actually have the ability to click on things that you see and change their properties. So for instance, if I wanted to click right here on this full screen content, which is these words here that say bar talk, I could come down here to where it says text color, and I could actually change that. I might want to change this to maybe I want something a little more snazzy. Maybe I want something like maybe a real blue, not just a light blue, a deeper blue. Great, so I've already made a change in what the UI is going to look like. And underneath the hood, Android Studio took all of those particular clicks and converted it into the necessary description of XML that we'll be going into in the future. But it did all that for me. It's a really efficient way to be able to make changes and get feedback about those changes on the fly. Not only that, but I can actually start going through here and change what device I'm using to see this on, whether it be a tablet or a phone, of all different types of resolution types. I can even make custom ones and see it right there in front of me, so I can anticipate exactly what my application will look like for a wide variety of people. So you've made a change to this application. You might be wondering, what exactly are we doing right now? What is this app? Well, if you've ever been in a large crowded area, such as a bar, and you want to say something to someone far away. This application solves that. It's called Bar Talk, and it's going to be the first application you're going to run. All you need to do is go over here to the play button, click it, and you'll see that Gradle, the system which compiles things, is working for us down here. And when it's done, it's going to give us a pop-up that says, hey, your compiled application is ready to go. Where do you want to deploy it? Now, normally you would only have the opportunity to do the emulator, and you'd have to create a virtual Android device. You also could plug in an Android phone now if you have one, and use that to actually see your application run. But you'll notice that I have a running device here. This is actually not something that's plugged in. This is the other tool that I'm really excited to be using in this program with you guys. This is Genymotion. And rather than using a software emulator which comes with Android Studio, we're going to be using Genymotion as a transparent layer to turn your computer into a very powerful cell phone that you can set up and use much quicker and much faster. Now, this is the Genymotion emulator. The instructions for actually setting Genymotion up are better for you to just follow along online and install. I happen to have set up a custom phone for 4.3, not KitKat. I'm going one level behind. But I do want to show you one trick with this emulator in case you happen to be wanting your first experience to be with your own Android phone. If you go over into your settings for your phone and you go down to About Phone, you'll see this thing here that says build number. Well, there's a little trick to turn you from being an Android user into an Android developer by touching that over and over again. And I'm clicking and clicking, 3 steps away, 2 steps away. When you do this one more time, you unlock a secret menu that if I now go back, I will see here in my menu, Developer Options. If you click on that, you want to click this box right here to enable USB debugging. That is going to enable your phone to now work as a developer phone and allow you to connect the power of Android Studio to a real device. For now, though, I'm going to leave this alone because I'm using Genymotion, and that's what I'm going to be using primarily to show you around. Rather than doing that normal hello world kind of thing, we're going to actually have our first proof that Android Studio is running be a useful app. An app that you can actually go out tonight and use in public. Let's try it. I'm going to click this particular device. I'm going to click OK. Now you're seeing all this stuff pop up, and we're going to go over what those tools mean. But right now, the debugging area has basically shown up. We didn't even have to select it. It's just coming up, giving us a log of how things are going. I'm going to go back over to Genymotion. If I were actually to have this on a device in a crowded area, I would just touch it. What do you want to say? I want to say, I made this. And now your environment is all set up, as well as having just made an application that you can go out and use right now. So we've talked a little bit about arrays, but let's look at what they look like in code. Here on line 15, I'm going to start creating an int array, an array of ints. I'm going to type the word int, but I don't want just one, I want an array of them. So I'm going to use these square brackets to denotate that I want an array. The next thing I need to define is a name. It's mine, so I'm going to call it my array. Then you see an equal sign. Now that doesn't mean that it equals. It's actually called an assignment operator. And what it means is that whatever happens on the right hand of this particular statement is going to be assigned to that variable, my array. The int and the brackets denotate what type of data my array is. So in this case, I'm going to create a new int array with 5 positions. So again, we have the data type, the name, we're creating a new one in memory, and notice that we have to specify how big it is. So currently that int array is just filled with zeros. That's what ints are initialized in the very beginning when they're allocated. So I'm going to have to do this and actually point to a position on the array, in this case the first position, which is the 0th position, and actually put in a value for it. So I'm going to assign that one to 0. Then I'm going to assign the next one a value of 1. Then I'll assign the next position a value of, let's say, 17. Then we could put in
42, that's a really good number, and so on and so forth like this. Notice that at the very end here, I'm actually going to have to put a 4 for the last position, even though it's 5 up here. That's because we started with 0. So that's the long way to define an array. We can also define an array using a little shortcut that looks something like this. Now notice I've used curly braces. However, I'm not going to be writing a block of code. They're just a shortcut for doing exactly what we did up above. So here I'm going to be just putting in those same numbers. And it's a little bit easier to read if you're doing a real small array. The length is implied by how many elements are in it. Now we're going to continue to show you a bunch of different data structures, and each of them has a certain advantage or disadvantage. This is the most basic way of organizing data. It's incredibly fast. If you want speed and you want performance and you don't mind having to do things manually, then arrays are the right data choice for you.
A computer stores an array contiguously in memory, so while I've laid them out evenly spaced here, it's not quite like that. It's usually one after the other after the other. And if we wanted to read through the array, we could do it very quickly and examine each element. However, if we wanted to find, say, the third position element and its value, we'd count through 1, 2, 3, and then actually reveal that value. We wouldn't look at each value simultaneously.
Here we're entering into a very, very powerful API that Java provides. It's the Collections API. And what this is a way to do a lot of common operations for storing data, and it gives us all these particular tools, and we're going to introduce them to you starting with lists. The list family consists of many different types of lists. We have things called array list, linked list, even vector. And these are really, really good for if you want to access elements very frequently by using an index. The implementation like array list provides faster access if you know the index. If you want to store elements and you want to maintain the order that they're in, then again, lists are for you. So let's start with the old way of doing things. Here I'm going to have a string of days of the week. So just to show you how this would normally look, let's zoom out just a little bit. So here, right, I have these elements. I do want the days of the week to maintain the order that they're in. Otherwise, I'm going to get very confused when my alarm goes off. Remember again that this here is not a block of code. It's just a shortcut way of defining an array. When we define a collection in Java, we use this special notation of using angle brackets like this. Inside of them, we define what it's a collection of. So in this case, I'm putting strings because I want to have an array list of strings. Now it's red right now because it needs to import that. So I'm going to press Option Enter to fix that error. If you notice up here, it's now added array list to my import. You'll see that often as we go through these collections. So adding to it is as simple as actually just using this add method. I can add a string, I can do it again, and it will just put this one as the first element or 0th element. It'll put this one as the second element or first element position. So to make this equivalent to our days of the week, I'm just going to rename it on the fly real quick, and here I go. So now what would happen if I for some reason forgot about Wednesday? Oh, how would I actually put something now in between there? Well, if I had an array, I would have a problem because I would have to take an array and I'd have to create a new one of a larger size. I'd have to take the first two elements and I'd have to put them into the new array. Then I'd have to take the new element that I want, which would be Wednesday, and stick it in, and then finally go back to the original array and put Thursday in. Well, this is a pretty common operation to want to keep the order of everything but just do an insert. Well, that's where the Collection API really gets to shine. I can now just say
position 2, Wednesday, and as you can see, it's asking for an index and an object, and I can insert it without having to write all that code. The next collection API we're going to learn about is sets. The set family consists of many different things like hash set, tree set, linked hash set. Again, they are all part of the same family. The thing that's special about sets is they make sure that everything has a unique element. That means there can't be any duplicates. So if you want a collection of unique elements and don't want any duplicates, then sets are for you. All set implementations follow the general contract of uniqueness, but also add their own features. For instance, tree set is a sorted set. So I'm going to use a hash set, and again I'm using the angle brackets in order to define what it's a hash set of. In this case, let's stick to strings. Again, I'm going to solve that issue with the import statement real quick. Now, I can do the same type of add maneuver I did before with a dog, and I'll add a cat, and I'll add a moose. But if I then try to do something like add a cat again, this would not actually result in a new element being added. It would remain an element of 3 pieces to the set. Sets are a perfect collection to store user or user IDs because you don't want to have duplicate values for the same person. So now that you've seen a couple different ways to store data, let's take that idea of uniqueness to the next level. So there's another family of collections called maps. In that family we have things like hash map, we also have hash table, all different variations on these maps, tree map. So what is a map? Well, a map is a key value pairing structure. You're probably going to ask, what does that mean? Well, a key value system is one of the best ways to be able to store readable data in a way that you can actually find things in a system that makes sense to you. So for instance, key and value. We already have a system kind of like this when dealing with arrays, where we kind of use the position as the key and the value being what it actually points to. So if I had an array of strings, for instance, I would have these in an order, but what happens if I end up having a huge array of different things, and I get to the point where I actually want to talk about something at the very end? Well, you know, these keys that I'm looking at here, they don't really make sense to me as a normal human being. I mean, I do know that they're numbers and I get that they're numbers, but it doesn't really help me if I'm trying to like look for a specific type of thing. So a key value pair system is what allows you to specify something to have a relationship like an array, but you can use any data type for the key. Let me show you. Let's say I have, let me create a new hash map. And as you can see here, we have a K and a V. We get to specify the type for K and the value for V. So I'm just going to have both of them be strings. So I can use some readable pieces in there. We'll call it my hash map equal to a new hash map of strings. So how do we use this particular collection? Well, just like this. You can say put, and you can specify anything for the key and anything for the value as long as it's a string of characters. However, that key needs to be unique. You can think of it like a position in the array. It just has a readable name. So if I want to put my key and say for my key we get moose. Now if I want to retrieve the value moose, I can just get it using my key. Much like this, get my key. That is actually going to give us the moose. Now I can use other keys as much as I want, as long as they're strings. Oops, we want to put that to put. So this allows us to have a structure that's really, really useful for specifying details that make human readable sense to us. Let's say let's say I wanted to actually use this as a uh, So you've heard that Java is an object-oriented programming language. Let's take a look So now that you know how to allocate an object, what if I wanted to do something at the very moment of allocation? Well, that's where a very special method comes into play, called a constructor. So if we look at this statement on line 22, we'll see a data type, a variable name, our new keyword, and then the actual class that we want to create an object from. Notice something else though. Parentheses. Normally we see parentheses when we're dealing with a method call. Well, in fact, that's actually what's going on under the hood. These two methods that you see here are of a family of methods called constructors. They're called that because they are called when constructing the object for the first time. Now, even if we didn't actually have our constructors defined, you see Java's not complaining. Well, that's because this particular constructor is generated for us if we don't define it. Notice that we have a public keyword and then what appears to be no return type. Well, that's because the name of the method and the return type are the same for a constructor. My class is going to return a my class object. So, what if we want to do something in the beginning besides just create it? Well, here I am creating another pointer to my class, but passing in the phrase other moose. Rather than calling the constructor here, it will now call this method, ignoring this one entirely. So, when we do this, what is my variable's member variable going to be equal to? Is it going to be moose, or is it going to be other moose? Let's watch. I'm going to go ahead and just log my object, and I will actually log the value of that member variable. I'm also going to log the value of my variable's member variable. So, we're going to expect this particular object to be equal to moose, but my variable is going to change. Sure enough, moose, and then other moose. That's because the order of operations are first, my class is created in memory. Second, anything that is a member variable is created, initialized, and instantiated if necessary. Third, the constructor runs. In this case, changing my variable from being moose to other moose. And now, with that information, you can create objects and create what happens at the very beginning of initialization. This is incredibly powerful because you can define at the very start exactly how your object should be set up. We've talked a lot about creating objects, including how to use constructors to do things in the very beginning of allocation, but what about getting rid of objects? Well, Java handles most of that kind of memory management for us with something called garbage collection. Garbage collection is the idea that rather than allocating and then having to manually deallocate memory, Java will actually keep track of how many times we point to an area of memory, and when that number reaches 0, it will release it for use by other resources in the system. So, if we were to do something like this, my variable would no longer be pointing to this particular part of memory. Instead, it would be pointing to nothing. At the end of this block of code, the garbage collector would actually be able to take this particular block of memory and release it for use to allocate something new. Now remember, when we're pointing one variable to a piece of memory and then another, it's not transitive. If I were to do something like this, well, this piece of memory is now being pointed to by both my variable and my object. This piece of memory here is no longer being pointed to by any object. It would trigger a garbage collection. If I were now to do something like this, and I'll comment this so that Java will properly run. you would see that this particular variable is now pointing to nothing. Well, what about my variable? Was it pointing to my object? No. My variable was actually pointing to this place in memory. So now this object is pointing to nothingness, but my variable is pointing to that same memory that my object was. These things are not transitive. Remember, they're just pointers. So we can point them at anything that we want all day, but it really depends on how many things are referencing a piece of memory before the garbage collector will actually run. So if I were to now do something like this, and actually print out the member variable inside of my variable, even though my object is null, my variable is still pointing to the original my object that was instantiated on line 22. And if we run this, we'll see moose, not other moose. What happened to that other block of memory? Well, it was cleaned up for us by the garbage collector. And that's why Java is such a powerful programming language. You can focus on the code while it focuses on managing memory.